Good morning, students. Welcome to the class of Technomethics. So today we'll be taking one question from the same chapter, Work, Power and Energy, where a chain is hanging on a table. Okay, so there is a table. Okay, let us say like this. Okay, and on this table, if these are if these are the legs of the table, okay, let us say, and on this table the chain is kept. Okay, a flexible chain of length L. Okay, the question is that a flexible chain of length L and mass M. Okay, so first of all we need to understand what is chain length. Chain length is given to you as L, right? Chain length is given to you as L, and mass of this chain mass is given to you as M. Slowly pulled at a constant speed up over the edge of a table by a force F parallel to the edge of the table. So the force will be acting at this point. Force will be acting at this point like this. Okay, and the chain is like this. So the chain is lying over here and it is hanging over here like this. Okay, and into the question it's mentioned that the chain is slowly pulled. So this is slowly pulled by a force at a constant speed up over the edge of a table. So this is the edge of the table. From here it is pulled up. Okay, by a force F parallel to the edge of the table. So this is the edge of the table and parallel to it a force F is applied over here, right? We need to assume that there is no friction between the table. Hi, art and crafts. So assuming that there is no friction between the table and chain, calculate the work done. So between the table and chain here at this point, we are saying no friction, right? So in this case, we need to find the work done. Okay, what is the work done? By this force in pulling this chain, what is the work done? This we need to calculate, right? So students, into this question, the force required to pull the chain, this force required to pull the chain will vary with the distance, right? So the it is equal to the weight of the fraction of the chain which is still hanging. So let us say if this length above the table which is lying on the table is x, this one. If the entire length of the chain is L and the section of the length of the chain which is lying on the table is x, then definitely what is the length of this part of the chain? This one which is hanging. This is nothing but this will be L minus x. Okay, so the two portions will be there. Okay, let me zoom a little. Here you can see the section of the chain which is lying on the table is x and which is hanging over here is L minus x, right? So the force required to pull the chain will vary with the distance. So we have assumed this x and L minus x over here, and it is equal to the weight of the fraction of the chain, right? So what is the fraction of the chain and how the weight will be varying? Okay, so it is equal to the weight of the fraction of the chain, that is L minus x by L. Okay, so this is the portion which is hanging downward, and with respect to total length, right? And if this fraction, this is the ratio which will be applied to the entire weight of the chain. Okay, and this will give you the force. This will be equal to force. This F will be the required force, and the section of the chain which is lying on the table is no, will not give its weight, but L minus x which is hanging over here, you can see L minus x is hanging, this portion divided by L, that is the weight of the chain which is hanging. This ratio multiplied by the weight will give you that equivalent force, right? Now we know that work done. What is work done? Work done is nothing but F dot dx, right? F dot dx, that means force into displacement. High Arts and Crafts Weekly. Okay, now here you can see the force is L minus x by L into mg. So to calculate the total work done, what we will do, we will integrate this, and this section of this dx section will vary from 0 to L, right? So just integrate it. When you integrate it, and the length of x will vary from 0 to L, right? What will happen? The length f, just put up the value of L, that is L minus x by L into mg dot dx, 0 to L, right? Now here you can see L minus x will remain here, and mg by L is the constant term, so we can pull it out. So mg by L will be coming out from the integration, and in this 0 to L limit, with the length of the chain varying from 0 to L, L minus x dot dx will remain, right? Now into the next step, what we can do, mg by L, mg by L will be as it is, and L minus x dot dx will be broken into two terms, 0 to L, L dot dx minus 0 to L x dot dx, right? So here you can see, let me squeeze a little. Here you can see mg by L is a common to both the integrations. Okay, so here mg by L will be kept outside the bracket, and here L dot dx, so L will be coming out, and integration of dx will be x, right? And the value should be from 0 to L minus, for this x it's x square by 2, and its value vary from 0 to L, right? Now simply put up the, this will be mg by L, right? And here L into, for the value of x from 0 to L will be, for the bigger value L, minus 0, right? Minus x square by 2, that is L square by 2 minus 0, like this, right? So this will further give you, the weight of the corresponding weight, and the work done will be mg by L, and into the bracket it's L square minus L square by 2, which is coming as mg by L square minus L square by 2 will give you L square by 2. So this is the total work done, and here you can see one of the L will be cancelled out with this, so this will give you mgl by 2, mgl divided by 2. mgl divided by 2 is the total work done in pulling this chain, which was hanging on this table like this. Okay, so students, what we did immediately, just going for the recap, the force, this force will be equal to the weight of the ratio of the weight which is hanging on the table. Okay, the concept lies over here. So here you can see L minus x is the weight of the chain, is the ratio of the length of the chain, which will be the deciding factor, which is the deciding factor of this weight of chain. Okay, so L minus x is hanging downward, x is lying on the table, so L minus x by L is the ratio multiplied with the total weight. Here you can see this will give you the weight, or which is equal to F, right? Just equate the force. Now work done will be F dot dx from 0 to L. From 0 to L, because the length of the chain vary from 0, because that means when there is no portion of the force which is hanging with chain which is hanging, then the L will be 0, L will be 0, and for the length of the chain which is hanging, which is just pulled up over here on the table, which is the total length, which is equal to L. So work done is F dot dx. So just put up the value of F as L minus x by L dot into mg, which is the ratio deciding the weight of the chain dot dx. Integrate it and simply get the value of the work done, that is equal to mgl by 2, and this is your answer, students. This is your answer. So with this we can wind up today's session, students. Thank you so much for being connected. Take care. Bye bye.